Hello everyone, welcome back. We are back here with a repair and the restoration of the Hitachi HA-270 amplifier. Well, if you haven't seen the last video, I'll do a quick summary. So the amp was brought in fully working. The only complaint was there were some issues with the switches, not always registering correctly. That the volume control crackling, these kind of things. So I guess it was only a matter of cleaning the switches and that would be it. But when I was in here, I decided to do a decent overhaul anyway. So apart from cleaning all the switches and potentiometers, I also did a full recap in the last video. And I also noticed that we had issues in the power supply section with these resistors here that were clearly have been overheating. Noticed that some capacitors in the power supply were totally shot. So that we'll have to cover in this video. I also noticed some big issues here with these connectors on the back. See, they are completely loose. All the plastic is broken. See, it just breaks off when I touch it. So this entire bank of connectors needs to be fixed or replaced. And then I got stuck because I didn't have the correct resistors here. I didn't have a couple of capacitors that I didn't have in stock. I didn't have a replacement for the filter capacitors, and I didn't have these sockets here. So I got stuck. In the meantime, I received all my components that I ordered. See, so we can continue, I guess. First thing I'm gonna do is finish off the recap, because there are two capacitors here that still need to be done, and these were .22 microfarad, so 0.22, and obviously I didn't have those in stock because you rarely see capacitors going to such a small value. So I ordered some new ones. They are super tiny. They are Nishikons 105 degrees. Also quite important because they are close to this area where we have a lot of heat. So that's the first thing I'm gonna do, just to finish off the recap here. These two light blue ones are the only original ones still left. We're gonna replace those two. And let me just show you how I do it, because there's something interesting I would like to show you. So how do I desolder these capacitors? Now, I don't have a desoldering station. What I use is this. So I have it's like a desoldering pump, but it's a heated desoldering tool, and it's extremely cheap. I think I paid like 10 euros for this or something. It's really, really cheap compared to a desoldering station, but it works incredibly well for the price. It shouldn't be, for this price, it shouldn't work that well. It's amazing, actually. Now, it does work better on a PCB like this, which has traces which are large enough. The smaller the traces get, the less good this works, because you can't really change the tip, or I don't have different tips for this tool. So it is rather large, the tip. But for PCBs like this, they are really the perfect size to use a tool like this. So let me just show you. I think we need to desolder this capacitor over here. That's one leg desoldered. That's the other leg desoldered. And I think it's already loose. This one is still a bit stuck. This one is bent, this side. There we have it. See? It's as easy as that. And if you have a PCB with decent sized pads and decent sized contact points, then this works almost as good as a desoldering station. The only thing is, obviously you don't have any heating control, so you have to be careful because the thing heats up more and more the longer that you plug it in. So you need to be careful and do not apply that you don't apply too much heat. Also, what is you also need to pay attention to is, since you suck in the solder into the gun, at a certain point when you charge it again, it will push out the solder that you sucked in previously. So every time when you push it in again, when you use the pump, you have to aim it away from your PCB, because sometimes it spits out a blob of solder and you don't want this in your circuit or on your PCB. But that's it. I mean, for the rest, it works really, really good. It shouldn't work that good for such a low price, but I use it on PCBs like this, and it works really well. It's really convenient. And then obviously soldering in the new one, it's just straightforward because the holes are already cleaned, and yeah, it's as easy as that, and it goes as fast as that. Now, if you need to do a lot of desoldering, I guess that the desoldering station is still more convenient than this. But if you only, if you don't have to do desoldering often, it's nice to have something like this, just for when you need it from time to time. Okay, let's do this again, just so to show you that it's not a fluke. That's one leg. That's the other leg. And then we just make sure that both legs are loose. And see, the capacitor just drops out. Yeah, great. Okay, now let's have a look at these resistors over here. Let me remind you what actually the issue was. I discussed it extensively in last video, but I'm just going to refresh your mind a bit. So we have 4 resistors over here and 4 resistors over there. They are each 1.5K, half a watt each. And they are wired in parallel, so that means we have 375 ohm, 1.5K divided by 4, 2 watts, half a watt multiplied by 4. So these 4 resistors in total is actually one 375 ohm 2 watt resistor. If we look at the schematic over here, we have here our rectifier, our filter capacitors, and here we have these 2 banks of resistors. See, 1.5K, half a watt. So 4 over here, 4 over there. So they are on the B plus and on the B minus. And here we have the zener diode that is regulating the voltage to 13 volts. So this is a 13 volt zener. So these resistors, they are dropping the voltage basically to have it dropped from 36 volts to 13.2. Now obviously the problem is that they simply just mounted these resistors here onto the PCB, which is, according to me, a very bad idea, and it's a bit of a design flaw even, I would say. So what I'm going to do, I picked up from DigiKey some new ones. So these are 1.5K, 3 watt each. So I'm going to replace each of these with one of these new ones, and I'm going to mount them a bit higher, just like these power resistors are mounted over here. See, for these ones, they did mount them like a centimeter or more above the board, but for these, they didn't bother, whereas they are running much, much hotter than these guys. It's really bad design practice. I think this is a flaw in the design of this amp, and if you have an amp like this, you really should take a look at these and consider if you don't need to swap them or change this as well, because at a certain point, these will fail. They will definitely fail. And the problem also, as you see, because of the heat, see, these are loose, so they have broken solder joints at the bottom. And if one of these go out of contact, then the resistance will go up with all really nasty side effects. I mean, this is not future-proof the way that they did it like this. So I'm going to desolder these, try to get them out. PCB in the back is really bad. All the solder joints are cracked. So let me just try to get these out and then mount new ones in here, but a bit better than how they are mounted here at the moment. So okay, I desoldered here these 4 resistors from the board. I also took out the zener because I also want to check that one. And I cleaned up the soldering pads. So it's really difficult to remove these things if they are heavily oxidized. So the easiest way to do this is to add a bit of new solder, and then you can desolder it much better. So if you are struggling to desolder something which is heavily oxidized due to heat, then just add a bit of new solder. That helps a lot. Now, also, when you have an area on the board which has been overheating, like this area has, pay attention that the tracers are still okay, because see, this trace here, this is completely coming off, completely loose, completely detached from the board because of the heat. And see here as well, also it's coming off. So what I'm gonna do now is put in the new resistors and make sure that this trace is repaired here, so that we have a good and a stable connection. And then we're gonna see if we can test these zeners, because I was so stupid to not order any new zeners for this, so I don't have any 13 volt zeners in stock. The ones which are in here are 1 watt also, so not difficult to find, but I don't have them, and I just want to check if the ones that are in here are okay. So yeah, then I can put these back. So these over here, these are the resistors that came out of the board. Well, the first 4. Let me just show you what they read. So they should be 1.5K. So first one here, 1.16. So that's done. This one, 1.26, also bad. .17, and the last one, 1.26. So these are also cooked. It's a good thing that we're gonna replace them. Okay, so let me show you the setup that I got here. This is the zener that I pulled out of the circuit. This is my power supply, and I have a load resistor here on the negative side of the zener. I'm gonna apply a reverse voltage, see, because I have the positive lead here connected to the negative side of the zener diode, the negative lead to the positive side, so I'm gonna apply a reverse voltage, and then I'm gonna measure the voltage with my multimeter here across the zener diode. And then we should see that this is a 13 volt zener, so when we increase this voltage, it should cap it, let's say, or it should regulate it to 13 volts. That's the purpose of a zener diode. So let me just enable my power supply. I'm now, I have it set at 2 volts. See, and we have nicely 2 volts across the zener. Now I'm slowly going to increase it. 3 volt, 4, 5, 6, 7, 8, 9, 10 volt, 11, 12. Now we should start seeing the limit, because now we go to 13. And see, we are only getting 12.7. So we're going to go 14, 15, 16, 17, 18, 19. And I see that it's now also starting to pull current as well. I have 3 milliamps of current going through at 19 volts. Let's just put it on 20. So I have 3 milliamps of current going through here on my power supply. It's capped here at 12.8, which is perfectly fine. And that proves that this Zener diode is actually working as it should. So in standard mode, my power supply can go to 31, and see if I am at 31, then I get almost exactly 13 volts here, and then it's pulling 14 milliamps. So that's actually not too bad. I'm gonna test the other Zener diode in the same way, and if that one also tests fine, then we can just put both of these back, replace the resistors, and rebuild this entire power supply section. See, that's the other Zener. Also now at 31 volts, also drawing 14 milliamps, but it's a bit higher. So it is like 0.3 volts higher. So we have a slight imbalance between the two, probably because the other one suffered a bit too much in its life. But, well, I guess that will still be okay. I mean, I don't think that this is a critical difference or a critical issue. So I think we can put both back safely. I don't have any others in stock anyway. So I think this is okay. Okay, so this entire section here has been rebuilt. Here you've got 4 resistors, and here on this side. This is the part where the traces came loose, so I took some of the leads of the resistors, bended them over, and soldered all of the leads together, also to the traces of the PCB, same on this side. So yeah, then we have a bit more of a reliable connection. And here as well, this trace wasn't broken, but because it was here on this side where it was coming loose, I decided to pull another wire here just to make sure that we have a good connection here for this trace as well. On that side, the damage was much less. The resistors that came out of here were also closer to the 1.5K. They measured between 1.3 and 1.4, but they were still off as well. So that section was dying also, but it was a bit behind this one. But here I did the same thing. I used the lead of one of the resistors here as a bridge to make sure that we have a good connection here, and to take some of the stress away from these traces as well. Okay, so let me show you how it looks on the top side of the board. And that's how it looks on the top side. As you see, I put these resistors a lot higher than the board, not straight on them, just a couple of centimeters above. I also varied the height a bit so that they have a bit more distance from each other, so that they can cool. The added value of this is obviously that these resistors now can also be cooled on the underside from the air, whereas if they are just very close together on the PCB, then they basically only can get rid of their heat via the top side, and now you have air flowing all around them. And so this should be much better than how it was. And I put the both original Zener diodes back, and then we'll see what we get when I power it up again for the first time. I would like to power it up now because I have done a lot of changes here. I mean, I've changed all the capacitors, I've rebuilt this entire section, and normally I try to limit the amount of changes that I do between tests, but in this time, because it's so difficult to take it out and put it back in the cabinet, I decided to completely recap everything. But I can't power it up right now because you see, I still need to do here the filter cans. I already removed one in the last video. Where is it? See, so this is the one that I removed, and we tested in the last video also that this was bad. It also needed to be replaced. So I got some new ones. So these are Nishikons, 5600 microfarad at 50 volt. The original ones were 5600 microfarad at 40 volts. These are 105 degree caps. These were 85 degrees. So these are good replacements. And they are also smaller. The only drawback is obviously that they are snap-in capacitors and not with leads. So yeah, and obviously that doesn't fit. So I'm gonna need to drill some new holes here to make sure that this capacitor fits on there. So I guess that's the next job. So the new filter caps are in place. I had to drill slightly new holes here. If you need to mount these kind of new capacitors, it's best to just check in the datasheet what are the size of the holes that they expect. In this case, it was 2mm holes and 1 centimeter apart, which was slightly bigger than the holes that we had here on the board. So these two I reused. These I drilled out. And then, yeah, the original holes here and there, they were a bit too far away. So I drilled a new one over here and a new one over there. And then I made sure that we had a good connection. I scraped a bit of the silk screen away here in both cases. And I made sure that we have a good solid connection between the capacitor and the the pads here on the PCB. And that's how they look here on the top side. Pretty clean actually. This is glue from the original one that is still there, but they are quite a bit smaller, and yeah, looks to be okay. Now I'm going to try to put everything back together and power up the amplifier and see if I haven't made any funny mistakes. So that'll take a bit of time to get everything back together. I believe, honestly, that I also should be able to power it up like this. I have everything connected. The only jumper wire that I had to do is this guy, because this is the ground connection of this PCB that I had to remove to get the PCB out. So that is jumpered. I have a plastic bag here so that this PCB can't short or anything. And I guess that's it. I don't have any speakers connected at the moment. I also don't have the VU meters, but that is also secure. See, I did put the connections in a socket like this so that I can't have any shorts. Yeah, so I believe I should be able to power it up just to check if there aren't any shorts, if I didn't make any big mistakes, and also to see if I don't have any high DC offset on the speaker terminals before connecting my speakers. Yeah, honestly, this should work. Let me just power it up. I only have a 15 watt bulb in series at the moment in my dim bulb limiter, just to be very safe. Okay. That's clearly not enough, but I don't have any shorts, I think. Okay, let me go to, what is this, 25 watt? Yeah, the protect relay is already pulling in. And it's 192 volts at the moment. I'm gonna leave it at this at the moment. I don't seem to be having any shorts. Let me just check the, oh, you can't see this. Okay, right. Let me check the speaker terminals. Okay. 10 millivolt. 5 millivolt. Still dropping. 1 millivolt. Okay, so that seems to be very good. Let me hook up some speakers and then we can see what we get. Okay, I got some speakers connected and I get it set here to the phono input, so then at least we should hear some hum. Okay. Nothing. Absolutely nothing. Ah, maybe I have the not the right. Yeah, I don't have the speakers enabled. Wait, let me. Ah, there it is. Let me go to a 60 watt bulb. Okay, so it's now getting to 210 volts. These guys are warm to the touch, but not as hot anymore as they were with the previous ones in there. Maybe I can, oh, so this is a 40 watt bulb. Let's go to a 60 watt. Now I have 230 volts going in. Okay, let's have a look what we have now with 230 volts going in on the B+. Okay, one side simply to the chassis, other side here to one side of these resistors. I think it's that side. Minus 36, on the other side we have 36. And we should have 36.2 on each side. Okay, and on this side we have 13.2. And here we have 13.5. Wow. I shorted something there, I think. Woo! I slipped off this resistor and I shorted something, but it's okay. 13.5. 13.5. 13.3. Well, minus 13.3. But this is really good, actually. Let's turn it off again. Now, the only thing that I'm going to do now still is to swap the transformer to 240 volts. This amplifier is here for the European market and it was only set to 220, but the transformer in there is universal for different markets. And you can swap it to 240 because see, we have here different possibilities depending on the region, on where you bought the amp. So we have a circuit for Canada, for France, or Germany, Sweden, so let's say Europe, and then for Asia and the Latin American countries. Now what is in my amp is this schematic over here. And the pity about that one is it is only 220. There is no way to select between different voltages. See, this one for Canada is 120, but this one here you can select between 120, 220 or 240. Now, the difference is only in the wiring, and also that these two have additional AC outlets for powering additional devices that this amp doesn't have. But the transformer is the same. So it's only the wiring that is different. So we can deduce from this diagram how we should wire it for 240. Okay, so let's have a look at this. So these ones we can already ignore. Those are just AC outlets that we don't have. Here we have the power switch. Here we have a voltage selector between 120 or 220. So this one is now set on this diagram to 220. So we should also leave it in that position. And here we have the selector between 220 or 240, and it's also set to 220. So normally, if we follow the wiring over here, we should have the same result as the European schematic. So you see, we have the AC connected to pin 9, then we have the other part going through the power switch connected to pin 2, and then we have a loop between pin 6 and pin 3. Okay, remember that. So if we follow here, indeed we have one side of the AC connected to pin 9. The other side of the AC is going here through this switch connected to pin 2. Okay. And then we have here, we should find here a loop between pin 3 and pin 6. So if we follow pin 3, we go here through this 220 voltage selector circuit. Then we go to there, through this switch, like this, and we go indeed to pin 6. Okay? Now what happens if we would select here 240 instead of 220? So this guy remains the same, but this we switch to 240. Then, if we follow pin 3, yeah, that is unconnected, so we need to follow pin 6, I guess. So we follow pin 6, it goes like this, through this selector switch, back to there. Then this is obviously in the other direction, so we go like this to 240, like that, and we end at pin 4. So what we should have is a loop between pin 6 and pin 4, instead of 6 and 3. So if we go to our schematic here, this one, if we put this loop, if we change this from 3 to 4, then we should have set the voltage for 240, the input voltage. And this makes sense if you look at the schematic over there. See, so the input voltage is here between pin 9 and pin 2, and you have these two windings which you should put in series. So if you have a loop between pin 6 and pin 3, see, you have less windings of this part compared to if you use pin 6 and pin 4. So it makes sense that this is then set for a higher voltage because you will have more windings. Your connection will be like this, pin 9, then 6, 4. You'll use both windings in total. Now, if we look at the power transformer, you see that this is this loop I was talking about. And then you see here that we even have these connections labeled. See? So this one is going to pin 3. And on this side, this is pin 6. So the only thing that we should do is move this wire from there to there. And that should be it. Okay, so I have the transformer swapped, and I have now 239 going in, so that's really high, but that's how it should be, because the transformer is now set for 240. And let's see what we get now straight after the rectifier. We get on one side, we had 36, now we have 34.5, minus 34.5, and on the other side, 34.5. And here on this side, on the resistors, we have minus 13.2, and the plus is 13.5. And according to our schematic, we should have 13.2 and minus 13.4. So that is really good. And the input voltage is now slightly lower, which means less stress on these resistors, less stress on the zener, less stress on the rectifier. It will run a bit cooler. I think it's not a bad decision to, if you're using this amp today in European countries. Here in Belgium, we are at 235 volts most of the time on the mains. Swap it to 240 instead of 220. It's really easily done, and it will run everything slightly cooler. Okay, I've got some royalty-free music playing on the aux input. Honestly, that's sounding really good, and I'm only playing it through two small PC speakers. These guys are warm, but the previous ones I couldn't even touch them, so hot. So these are warm to the touch, but not excessively warm. Alright, so I've got the main board back in. But now I think we are up to the biggest challenge of the entire amplifier. And that's replacing these sockets. Yeah, I won't be able to find these exact replicas of this anymore. So I bought here new sockets, RCA banks. I've got a bank of 2 and a bank of 3, so in five in total. But yeah, you see, these are quite a bit smaller. I mean, they are much closer together. See, if I would just put these side by side, then you notice, yeah, it's almost one bank shorter in total. Also, they are lower. I mean, see. So if I would just fit them on the PCB, they are a bit too low. To make things even worse, the pinouts are different. So you have here, looking from the outside, you have first the grounds and then the signal pins. With these guys, it's the other way around. So you have the closest to the chassis, you have the signals, and then on the back you have the grounds. Also, the pins here are swapped. So you see, this is the left channel and the right channel. On these ones, they are also swapped around. So these pins don't match. So that means that I need to make some adaptation or an adapter to fit these on this board. And then we have the challenge of mounting them through here, which is also not going to be easy. I'm thinking about just cutting out these separations here, these separate compartments. For example, cutting out these two over here and then mounting this like this. Maybe sticking it through here. Yeah, I can't stick it through because everything is in the way. And then the idea would be to, if I cut this out, this entire section, make one big hole, or let's say one hole here and one hole there. Then I can mount these guys like this. And then the idea would be to take a piece of aluminum or a piece of metal and bolt it through here, and then drill holes in the correct places to have these sticking through. But that's gonna be a lot of work, because everything needs to line up correctly, and also I need to make sure that it lines up, that the pins line up here and everything. Oh, this is gonna be a nightmare. And this is quite a destructive way of, obviously, of changing this, but I don't think I have any other choice. See, these things, they are completely shattered. On the inside, the contacts don't even stay in place, so if you plug in a cable, then yeah, the contacts, they just fall out on the inside, so there's no way I can salvage these. Yeah, let me think about this, and not sure if I'm gonna still work on this evening, maybe tomorrow, because this is, I think I need a fresh head for this. All right, so what you see here is more than a days of work in total, I think. I did it over multiple days, but it's many hours of work to figure all this out and to get these new connectors mounted and made sure that everything fits. What did I do? First of all, I removed here these metal supports, which were between the different sets of sockets. Here I removed one, and there I removed one. And so then these guys, they can fit in a set of 2 and a set of 3. Then I also mounted them on a prototype PCB. And then I also, I adapted the connection. So the PCB here is connected to the original one via wires to make sure that, the correct signal is going into the correct connection here on the PCB. Now, originally, this PCB was held in the case via the connectors. So the original connectors, they were screwed in place, and that was it. That was holding the PCB. Same thing with the connectors on the front. So that's not really great, because what you're basically doing is using the solder points here as a structural support, which is not a great idea. As a result, you can expect some cracked solder joints. I had some here as well, and here on this side as well, because on both sides the PCB is held in place with the connections on the back and with the switches in the front. The PCB itself is not structural, which is bad. But now it would be even worse, because I'm putting these connectors here in place, and see, they are not they are only attached to the PCB via this set of wires. So I added a support here, a small support bracket. I drilled a hole that I countersunk to screw here the PCB directly into the chassis, so that we have a mechanical support for the PCB. Yeah, let me show you this from the other side. Oh, wait, then obviously if this would go in, so then this would go in like, let me show you, like this, more or less. Yeah. Okay, so see, so that fits. And then what I did is I created this bracket plate. I just took a piece of metal, so a piece of scrap metal. I drilled the holes for the connectors here, and also some holes for the screws to keep the connectors in place. I'm gonna drill a couple of more, I think, because I'm gonna reuse some of these holes to fix it also into the cabinet. And then I sprayed it black just to make it look better. And then see, this can go over the connectors, and that should look pretty good. So I still need to do the mounting, but let me show you how it looks now on the inside. See, so that's how it looks on the inside. So this is the PCB where so the connectors now are mounted here to this PCB, and then you have the wires for the left, right channel and the ground for each connector. They are going underneath and connecting to the original connection points of the original PCB. And then you see, now this is resting here on the heatsink, which is not great. So I will lift this up a bit and hold it in place via the new bracket that I added. So that's it, more or less. This took me a lot of work to get this all figured out, how it was going to fit in there, and how I need to do the adaptations for these new connectors and everything, and also out of which material was I going to make this bracket, and then making the bracket, and man, see, so this is how it looks underneath. So now if you need to do the same thing, then at least you have an idea. If you come up with something more easy to make, good for you, but this really took a lot of time. But it works. I already tested the amplifier with a connection to the aux and to the tuner input, and they work fine. So yeah, I think I'm there. Now let me just put everything in here, and I'll come back to you when I have when that's done. Okay, I got everything back in place, and honestly, I'm quite happy with how this looks. It's not too conspicuous, and it's very sturdy. It's really attached well here to the back of the amp. And yeah, like I said, I'm really happy with how this turned out. Okay, so I think we are mostly done here with this part. Finally, I just need to still reattach the ground wire here for this PCB. And then I will fire up the amp and see if we can, if we need to adjust the idle current. So yeah, let me just get that set up here. Okay, idle current adjustment. It's very easy. You should measure across resistor R716L for the left channel, R for the right channel, and you should measure 8 millivolts, which plus or minus 4 millivolts, which means an idle current of 40 milliamp plus or minus 20 milliamp. So I've let the amp warm up for 10 minutes or so, and you see here we're really close to the 8 millivolt, and it's fluctuating a bit around. See, we're at 7.95 now, so I don't think we need to do any adjustment here on the left channel. It's nearly perfect. If I would have had to adjust it, then it's this guy here, R751L, which is the potentiometer just next to the preamp PCB here, or the equalizer PCB. For the right channel we have to do the other one, R715R, and that's this guy over here. So let's take a look at the right channel. Because the left one, see, it's fluctuating over around 8 millivolts, which is perfect. So let me just go here and see that I don't touch anything with my leads. And let's just check the right channel, the left channel. Wow, okay, the left channel is way off. Well, technically, it's still in the margin of 8 millivolts plus or minus 4, but I do think that we're going to balance this a bit better. Let me see if I can do that and how twitchy this potentiometer is. Okay, that's the wrong direction. No, it's perfectly doable to adjust this with this potentiometer. There we are, minus 8, perfect. Done, I think. I'm just gonna let it settle and then maybe adjust it again to 8 millivolts and then check the other channel again. And if they're both stable around 8 millivolts, then we'll call it a day. Okay, so as you see, I've already put the front panel back on, and I'm working here on a solution with some LEDs to replace the, to put some light here on the VU meters, because if you remember, the incandescent bulbs inside were blown. But I think I'm gonna leave it at this for this video, and then you'll see this in the next one. So I'm gonna finish things up here, put these LEDs inside, and then in the next video we can basically see how the amp is performing, check a bit how much power we get out of it, do some tests, and you can also see my fantastic solution with my LEDs. So yeah, I'd like to thank you for watching, and if you want to see the finished result, then yeah, subscribe to the channel so that you can see the last video in the series popping up, and then I'll see you next time. Take care, bye bye.